Okay, y'all ready? All right, guys. So here it is. So we're just going to continue from yesterday. And then this one here is called the second derivative test for local extrema. There is a catch to it. The first derivative has to equal 0. And it says theorem 5. That's because it's coming from the Demena textbook and they're counting theorems. We're not counting here, so don't worry about that. It says, number 1, if f prime is 0 and f prime prime is negative, then f has a local maximum at x equals c. Remember what I said yesterday, guys? It is so easy to become a robot. I don't want you to be a robot. I don't want you to be a robot. But if you want to be a robot, you can just memorize things and you'll get it correct. How does this look visually? So I will show you number 1 here visually. That number 1 is this number 1. So it says that my derivative is 0, and it says that the second derivative is negative. If the second derivative is negative, tell me what it means for f, that it's what? No, not decreasing. If the second derivative is negative, f is concave down. So here it is concave down. This is f. And here is my f prime equals 0. So notice f prime equals 0 right there. So what do you notice if f prime is 0 and you're concave down? That's a what? It's a max. Yeah, the horizontal tangent comes from the derivative equals 0. So there it is. That's the second derivative test. If your derivative is 0, and your second derivative is negative, at that point where the derivative is 0, you have a max. F has a max. Make sense? Here it is, number 2. I'm going to do this one in blue. It says if the derivative is 0 and your second derivative is positive. So if the second derivative is positive, what does that mean about f? Concave up. So here's concave up. And here at this point right there it is. That f prime is 0 there. And what do you notice? You have a what? Min. And that's all it's saying. So there it is, number 1 and number 2 visually and color coded. Was that simple, guys? Yeah, pretty straightforward. So example 5, it says use the second derivative test to find the local extrema. Now there's 2 things that I got to do first. I got to first find where I have the derivative 0. So there's another way to find max. Child, what was the other way? Wherever the derivative changed from positive to negative, that was a max. And wherever the derivative changed from negative, to positive, that was a min. Don't be a robot. I know you can be a robot really easily. Make sure you know why. If the derivative changes from positive to negative, that means my f was increasing and then decreasing. Look, that creates a hill. I have a max. If your derivative goes from negative to positive, f went from decreasing to increasing. Look, you have a, what is it called, a valley? So look, you have a min. Make sense? Cool. Everything makes sense, guys. So here we go. So use the second derivative test. So first I got to find the first derivative. So write f prime of x equals, and I got to find the derivative of that, just regular power rule, 3x squared minus 12. Are we still okay? All right, I'm going to factor out a 3, and I'm going to get x squared minus 4. I'm going to equal that to 0. And I get x, I guess I'll show all of it. X squared minus 4 equals 0, so x squared equals 4. So x equals plus minus 2. I guess. Are we still okay, guys? All right, so right now I have this. I have f prime of 2 equals 0. F prime of negative 2 equals 0. That's what I want. That's part of the conditions that I want to do the second derivative test. Now I'm going to take a derivative, again, a second derivative. So I'm going to go f prime prime of x equals, and I'm taking the derivative from right here. What's the derivative of 3x squared? 6x, and I'm going to go f prime prime of 2 equals 12, which is positive. F prime prime of negative 2 is negative 12, which is negative. That's how you say positive and negative. And I'll wait. All right, so now we're going to make statements. Statement 1, and I'm looking at at x equals 2. X equals 2 on f is it a max or is it a min? So let's see what we have. F prime of 2 is 0, and the second derivative at 2 is positive. So that means concave up. So if you have a concave up graph, it looks like this. Do it with your little hand. That point that you have a horizontal tangent is a what? Max or a min? Min. X equals 2 on f is a min, since f prime of 2 equals 0 and f prime prime of 2 is positive, comma. Hence, you know what? You don't have to write the hence part. I'll draw a little picture. Here's a little picture. It looks like this. That's like saying F. See? It's a min. You guys see that? All right. What about a -2? So a -2, the derivative is 0, and a -2, the second derivative is negative. So if it's negative, I am concave down like this. You're concave down, and if you're concave down, that critical point is a max. So x equals -2 on F is a max since f prime of 2 equals 0 and f prime of -2, sorry. And f prime of -2 is negative. And how does that look visually? Here's F, concave down, horizontal tangent, point up there. So there it is. I'm just drawing a little picture. That's not a plus, that's an F. Just trying to draw a little picture for you guys because I know you guys are visual. Cool or not cool? Yeah, there it is, guys. That's it. And I forgot to put the QR code. I buy all these little services like EV, and I never even use it, right? I hope you guys aren't like that either. If you pay for a service, monthly service, please use it. So I'm gonna start bringing in my QR code so we can do the. Remember what we did? I just didn't get a chance to put it in. All right, here we go. You try. True or false? If the second derivative is 0, then that coordinate, that's what it means, that coordinate is a point of inflection. Justify your answer. Is that true always? Sometimes, well, I kind of already said the answer there, dang it. If the second derivative is 0, is that always a point of inflection? No, not always. It's false. Sometimes it is, but not always. So false. Can we think of a counterexample? Yeah. Y equals x to the fourth. Y equals x to the fourth has a second derivative of 0. Check it out. Look. At second derivative of 0. Y prime or yeah, I already did it, so too bad. Y prime equals 4x cubed. Y prime prime equals 12x squared. Where is that 0? Well, it's 0 at 0. But y equals x to the fourth just looks like x squared, but skinnier. See? It's always concave up. So there was no point of inflection. Do you guys see that, guys? No? Look, do we know what a point of inflection is? A point of inflection is where we change concavity. Notice, look, if I set this x equals 0 at 0, look, my second derivative is 0. That's what it's saying. If my second derivative is 0, that's a point of inflection. Here's y equals x to the fourth. That's not a point of inflection. It doesn't change concavity. It needs to change from concave up to concave down. And look, why does x... I know, I'm writing super bad. Y equals x to the fourth is always concave up, no matter what. Do we see that, guys? So this is sometimes true, not always. You need to have a sign change. So let me put y. F prime prime must have a sign change for F to have a point of inflection. Chavez, what does it mean to have a sign change? That means that prime prime changes from positive to negative or negative to positive. Cool or not cool? Remember, guys, in the back of your head, remember that f prime prime being positive means that f prime is increasing. If f prime is increasing, f is concave up. Okay, just remember. Okay. All right. If f prime is 0 and f prime prime is negative, then f of c is a local max. Justify your answer. So if the derivative is 0 and my second derivative is negative, if second derivative is negative, what does that mean about f? It's concave down. Is it a max? Yes, this is true. This is your definition. This is your second derivative test. This is a second derivative test for local extrema. True. Second, I can't spell today. Second derivative test for extrema. Extrema is just Latin for extreme, max mins. Are we still okay, guys? All right, look, we're almost done. Last one. The x-coordinates of the points of inflection of the graph y equals x to the fifth minus 5x to the fourth plus 3x plus 7 are. So it wants the x-coordinates of where I have points of inflection. So I need to find where the second derivative changes signs. So here we go. I'm taking a derivative twice. Yeah, if you weren't here for the lecture, this is all like what? So make sure to look at that video, guys, or ask me directly or come after school. What's my first derivative? 5x to the fourth minus 20x cubed plus 3. There it is. That's my first derivative. Sorry, I didn't put y prime. Y prime prime, the second derivative, is 20x cubed minus 60x squared. That's it, right? So I'm finding where my second derivative changes sign. So I'm going to equal this to 0 because that's the only way I can go from positive to negative or negative to positive. Does that make sense to you guys? Okay. So I'm going to factor out 20x squared. And I'm going to have x minus 20, 40, 60, 3. I don't see any errors, but let me know if I have. And I get two values. I get 0 and I get 3. Don't just answer 0 and 3. Are we still okay? We're going to do a sign chart. I'm going to call that f prime prime. I'm going to plug in 0. I'm going to plug in 3. Work smarter, not harder. Do I have to worry about the 20x squared? Why? Because it's always positive. So you don't even have to worry about it. It's always positive. So pick a number to the left of 0, like -1, -2, negative whatever. Don't even look at the blue. Just look at the x minus 3. -1 minus 3. Is that a negative or a positive? Negative. Pick a number between 0 and 3. 1. 1 minus 3. Positive or negative? Negative. Pick a number bigger than 3. 4. 4 minus 3. Positive or negative? Positive. Where do I have a point of inflection? At what x value? 3. That's the only one that changes from negative to positive. X equals 3 is the only one where the second derivative changes from negative to positive. So I'm going to write a statement, even though this is not a free response. I'm going to write f has a point of inflection at x equals 3 since f prime prime changes from negative to positive at x equals 3. Cool or not cool? Yeah, there it is, guys. So, bam. Okay. If you weren't here,